Okay, so just like our laws of exponents color wheel showed us, we're going to distribute this 3 to this 7 and to this 4. So I'm going to end up with 7 to the third power times 4 to the third power. Yep. Yep. When you do the distributive property, you make the little elf hat, Santa hat, whatever you want to call it. Right? And so this is actually my final answer. Why can't I do anything else with these exponent values? Why not, Gianna? Yep. Final answer because they have different base values. Can't do anything else with that. Now I did have students in third period say, well, what if I just wrote 28 to the third power? That's the same thing, right? But I want you guys to practice, and you'll understand why when we get to down the examples, distributing it to both values in here. Okay, you would get the exact same thing if I actually found 7 to the third times 4 to the third is the same as 28 to the third. X times y to the fifth power. I'm going to distribute. I'm going to get x to the fifth, y to the fifth. Can't do anything with those, again, because they are different base values. You guys ready for a more challenging one?
Yeah.
Yeah, sure. Okay. Six squared times 7 to the fourth raised to the negative third power. There's a little bit of everything in it. So we're going to take little steps at a time. What's the first thing I should do here? Somebody just whispered it. Was it you, Ben? Distribute. Yeah. Who said it? Thank you. We're going to distribute the negative 3, which means we have to do negative 3 times 2 and negative 3 times the 4. We're going to get 6 to the negative 6th times 7 to the negative 12th. But based on what we just talked about earlier and what you guys took notes on yesterday, I can't have these as negatives. So what am I going to do to these terms here to make it mathematically accurate? Fractions, right? So they're both going to get moved to the denominator because they both have negatives. And then we're done. They both had to shift down. The very last step you should always do is if anything needs to be moved to the denominator or up to the numerator. Don't try to do it early, because then you'll get confused on where you were and what was negative, what wasn't. Always make that your last step. Hannah, what am I going to do? It's my first thing I should do. Distribute, good. So I'm going to get 8 to the 5th times 7 to the negative 20th. I know some of you are thinking, well, there's a negative exponent and there's a positive exponent, so what on earth do I do here? Anybody want to subtract? No, I can't do anything like that because they have different bases. What was that, Carmen? Just do the same fraction. Kind of. Kind of. Gianna?
With the 8 on top and then maybe a 1 on the bottom and then 7 be on the bottom and 1 be on top. I don't know what they're called.
You are saying yes, you're saying it, but you don't need to say the 1 part. But I know what you're saying. I know where you're going with this. So because this is positive, this is going to stay in my numerator. And because this is negative, this is going to go to my denominator. But what you were saying was 8 to the 5th over 1 times 1 over 7 to the 20th,
Yeah.
which is this exact thing. So yes, positives can stay where they are. Negatives have to be moved. And since this whole thing is technically over 1, that's why this stays in the numerator and this goes down to the denominator. Right, you only rearrange what has negative exponents. Everything else stays where it is. Ready for power of a quotient?
Yeah.
Can't wait. Math is awesome. All right, next page. Thank you. Power of a quotient. All right, so same thing we were just doing, we're going to distribute. So I'm going to attach this 5 here, and I'm going to attach it down here. So I'm going to get 2 to the 5th over 3 to the 5th. That's going to be my final answer. Why can't I do anything with that? The bases are not the same. But all right, so I'm going to distribute this negative 2 to the 1 and the negative 2 to the 3. So now I've got a numerator with a negative exponent and a denominator with a negative exponent. Where are they going to go, Carmen?
Do the fractions like the 1 on top and then have on the bottom 1 negative 2 and on the is it subtraction and then raise to negative 2.
So these are just going to flip-flop locations. Is that what you were saying? So because this has a negative in my numerator, this is now going to be positive in my denominator. because this has a negative in the denominator, it's now going to be positive in my numerator. They just change places.
How did you get 12?
It's supposed to be 1 squared, 1 to the tiny 2. No, you know what? That happened in third period too. Someone asked me, and I was like, I don't know how to write it smaller, but yeah, it's supposed to be 1 with a 2 exponent.
Wait, and why do you switch them?
Because they both had negative exponents. So in order to get rid of the negatives, I just have to put them in their opposite location. So they just flip-flop spaces.
Okay.
So then what's 1 squared? What's 1 times 1?
2.
1. So my actual final answer is just going to be 3 squared. Because this is like having a 1 in the denominator. So I can just rewrite my answer as 3 squared. Yeah? Okay. 4 to the negative 2 over 7 to the 6th, all raised to the 2nd power. Bless you. So I'm going to distribute because I've gotten really good at that. And I'm going to get 4 to the negative 4 over 7 to the 12th. Carmen?
No, put 7 to the 12th on top, and then
You're close.
so hard.
Is this negative, the 12?
No.
So it doesn't have to move at all. It gets to stay where it is.
So what about the negative 4?
So where am I going to move this?
To the
Down to the bottom.
To the denominator, right?
And then you put 1 over.
And the 1's going to be the numerator. Yep.
what?
So this one, I only have to move this down here. So this 1 is going to take over my numerator. 7 to the 12th times 4 to the 4th. Right? So if they have a positive exponent, I do not move them. They're good. They're meeting all of the mathematical requirements. They get to stay where they are. If they have a negative exponent, that's when I have to move them. Locations.
So if there's a negative and a positive, you put them both on the bottom?
If that's where the positive was to start, yes. So if the positive was up here, then it would stay in the numerator, kind of like the one we did on the power of a product rule.
Well,
Or the
so
8
if
to
the
the
positive's on the top, then what would you do?
So do you remember in this one right here, where we had 8 to the 5th and 7 to the negative 20th?
Yeah.
So this stayed in the numerator, and this got moved to the denominator.
Okay.
So you would do the exact same thing. Good question. All right, last one. 8 to the 3rd over 8 to the 4th raised to the 3rd power. So I'm going to distribute. I'm going to get 8 to the 9th over 8 to the 12th. These have the same base, so I can keep going with this. So what will be the next step? What do I do with that 9 and 12? Landon? Perfect. So 9 minus 12 gives me 8 to the negative 3,
How is it?
right? Because you take the numerator minus the denominator. And then you can't keep a negative here, so it has to go to the denominator.
Where did the negative go? Like, how do you just put no negative?
So that's what the trick is, like by making it like the reciprocal fraction, it's still the same value, but now we no longer have a negative exponent to confuse the math world. So that's kind of like what the notes were on that you took yesterday. So we rearrange it because these will be the same value, right? So if I do, in my calculator, if I do 8 to the negative 3, I know you can't see that, 8 to the negative 3, I get this weird number, right? 0.01953.125. Let me see here. If I do 1 divided by 512, I get the same number. And whoever decided this wanted these to be positive exponents, so it's just a different way of writing the same value with a positive exponent.
Okay.
Yeah. I don't love this situation, but they didn't ask me a few hundred years ago. So we just follow their rules still. Any questions? Any other questions? Yes.
Who made math?
I'm sorry?
Who made math?
I don't know, a bunch of really old people.
Oh, I don't like them.
Long time ago. Different parts of the world.